Hello everyone. Today we shall discuss about the next application of op-amp, which is summer circuit or adder circuit. So basically, as the name itself suggests, adder means we will add the inputs. Okay. For example, if we have two inputs connected at the input side of an op-amp, then uh, the output will be the sum of the two inputs applied. So in this summer circuit, we have two types. One is inverting summer and the another one is non-inverting summer. Okay, so inverting summer means we are applying the input to uh, the inverting terminal, and in case of non-inverting summer, we are applying the input to the non-inverting terminal. Okay, so here we can see negative sign indicates that it is a inverting terminal, and we can see here inputs are applied to the inverting terminal. Okay, V1 and V2 are the two inputs, and the currents are I1 and I2, and the total current which is flowing into the circuit is equals to I. Now, if we shall uh, derive the equation, mathematical equation for the summer circuit, initially we know that has this point B. Okay, it is directly connected to ground. The point B potential will be equal to the ground potential, and according to virtual ground concept, point A, the potential at point A will be equal to point B potential, which is equals to ground potential, which is a 0. So therefore, VA will be equals to VB equals to 0. Okay, this is due to virtual ground concept. Now, to arrive at the final equation, we need to write down the equation for the currents which are flowing through the respective resistances. If we start at the input side, now I'll write the current equation I1, which is flowing through R1. I can write it as I1 equals to V1 minus VA divided by R1. And I2 can be written as V2 minus VA divided by R2. So we know that VA equals to VB equals to 0. So this becomes V1 by R1, and this becomes V2 by R2. Right? Now we also know that the total current I is equals to I1 plus I2. Okay. The total current equal to sum of the individual currents, and the equation for I, which is flowing at the feedback resistance, can be written as VA minus V0 divided by RF. Okay, so if we substitute the value of VA, which is equals to 0, will remain with minus V0 by RF. Okay, now if I name these equations as equation 1, this one is equation 2, this is 3, and this one is 4. Okay, so this one is 4 and this one is 5. Now, if I substitute these equations, equation 1, 2, and 5, and equation 4, then I'm supposed to write it as minus V0 by RF. Okay, equation 5. Okay, I equals to what? Minus V0 by RF. Right, I'm substituting it in equation 4. So I1 from equation 2, which is equals to V1 by R1, plus I2 from equation 3, V2 by R2. So now I'll take out V0 and I'll send this minus 1 by RF to the right. So I will get RF by R1 into V1 plus RF by R2 into V2. So if in this equation, if I consider R1 is equals to R2 is equals to RF, then this equation 6 will become V0 equals to minus of V1 plus V2. Okay, so this is the final expression, what we expect from inverting summer. Okay, so summer means as we are applying two inputs, V1 and V2, we want the sum of those two inputs, V1 plus V2. And we are getting negative sign. It indicates that it is an inverting summer.